we continue looking at geometric transformations, and this time we will look at reflection over the y-axis. Now we have a general point. We're going to look at a general point and then look at specific examples. We have this point. This point is located at negative x, y. You can see we have to move to the left into the negative direction, so it's negative x, and then move up to the right. Move up to y in the y direction. So we have our negative x here and our y up here. All right, so it's negative x. We have our negative x and our y, so the point is located right here. Now what I want you to do, not yet, I'll give you something to do, but I'll do this part. If the point is located at negative x and it's reflected over the y-axis, it will remain at y, but it will be on the other side of the y-axis. That's why it's reflected over the y-axis. It's on the other side. So at negative x, y, it will go over to positive x, y. Alright? So if this is a, this would be a prime. What I want you to do is to pause the video and make that form that matrix that would cause a to be reflected onto a prime over the y-axis. So remember, this is positive x, positive y. Negative x, y is reflected over the y-axis to x, y. Pause the video and come up with that matrix. All right, so pause and do it now. Okay, you have paused the video and you have seen that you came up with that matrix. What was the matrix you came up with? Let us look at it. We're going to look at that matrix that you should have come up with. It's going to be a 2 by 2 matrix, of course. So this 2 by 2 matrix, let's say A, B, C, or let's do the calculation further down to get it all out of the way. We have A, B, C, D will multiply negative x, positive y to give x, y. Now what could possibly have happened to cause negative x, y, the column matrix negative x, y, to become x, y, positive x, positive y? Let's see. If we have A, B, C, D multiplied by negative x, y, what we would have is A times negative x becomes negative ax plus b times y will become by, and then c by negative x will become negative cx plus d by y will become dy. Now at the same time you ended up with x alone, so what could possibly have happened? Negative x became positive x. What it means is that A would have, if you have A times this, negative AX becomes X, right? You multiplied negative X by A and you get a positive X. So it means A would have to be negative 1, right? A would be negative 1 because A times negative X ends up as a positive X. Alright? So negative A would have to be negative 1. Negative A would have to be negative 1. So A times negative X is equal to positive X. We know that it is negative 1 that would multiply by negative X to become positive X. Alright, let me rewrite that part again. Negative 1, so it's A by negative X. Negative 1 times negative X equals positive X. So A would have to be negative 1, right? So A would be negative 1. So this is negative 1. What about B? B times Y is BY, but you don't see any sign of Y here, so it suggests that B must be 0. 0 times Y is 0, so it suggests that B must be 0. What about C? C times negative X plus D times Y. When you multiply C by negative X and you don't see any sign of the X, X disappears, so C must be 0. So the C must be 0. D times Y. Now D was multiplied by Y to get the same Y. So D times Y gives you the same Y. It suggests that D is 1. 1 times Y is 1. So this is 1. So the matrix that you would get, right? Let's write it up here. I'll write it in this corner. And we're going to use a different color. Let's use green. It's negative 1, 0, 0, 1. So it's negative 1, 0, 0, 1. Good. Oh no, where did this long line come from? Sometimes these lines on that just show themselves up. Alright, so let's erase parts of the board and redo it using that matrix. So what we have is, and let's do it in red, negative 1, 0, 0, 1 multiplies negative X, Y to get, what do we get? It's negative 1 by X, by negative X with positive X, plus 0 by Y, which is 0. 0 times negative X is 0, plus 1 by Y, which is Y, and that gives us X, Y. Alright, so there we have it. Alright, what we'll do is look at another video where we're going to perform this this transformation on a triangle. So I'll see you in that video. So until then.